Hello, I'm Alex Lazary from Pressure BioSciences. Today I'm going to show you an exciting instrument our company has recently developed. This instrument is a computer-controlled high-pressure generator called BioSycler HUB440. Our company is focusing on development of small benchtop pressure generators that are capable of creating hydrostatic pressure from atmospheric to 4,000 bars, approximately 60,000 pounds per square inch, and providing means of temperature control between -20 and +100 degrees Celsius for the samples being pressurized. Our equipment is being used for life science research, engineering, and small industrial needs. For years, scientists had to modify or create their own equipment to use high pressure in their research. Most exciting discoveries to date have been made using static pressure generators generated by traditional high-pressure syringe pumps. The introduction of the BioSycler HUB440 represents the revolution in the high-pressure research. This instrument is a plug-and-play pressure generator bundled with the USB computer interface and powerful software control suite, which enables any laboratory to perform high-pressure research right out of the box. In the heart of the HUB440 is an air-driven intensifier that is using compressed air to generate hydrostatic pressure up to 60,000 pounds per square inch or up to 4,000 atmospheres. It allows you to collect the pressure and temperature data and interfaces with the industry-standard equipment to make automation a snap. The instrument is capable of static and dynamic pressure control performed manually by the operator or driven by a computer program in an unattended mode. It's using low-voltage power supply and compressed air as input, creating pressurized water as an output. The BioSycler HUB440 has a small footprint which fits conveniently at the lab bench or near the test stand. It can also be rack-mounted if necessary. Open frame design allows rapid configuration changes to the system in order to accommodate your experimental needs. A number of accessories are available for use with the HUB440, including jacketed pressure chambers, temperature control options, high-pressure connectors, flexible tubing, check valves, and compressed air-driven high-pressure valves. A specialized pressure jump option consisting of a second pressure transducer, two rapid pressure jump valves, and a 15 milliliter reservoir enables the system to generate changes of pressure both up and down between specified pressure values in under a millisecond. Let's take a look at several examples of how the system operates. The HUB440 control software first presents the user with a splash screen where the user can select the mode of operation, access options, and tools for system calibration, configuration changes, and hardware tests. Once we chose the mode of operation, in this case BioSycler mode, and click Start to get to the main window, we can access the settings window where we can set the parameters for chosen task. BioSycler settings consist of the pressure level, number of cycles, on time, the duration of time where the high pressure is applied, and off time where the pressure is brought back to the atmospheric level. Let's enter 35,000 psi, 4 cycles, holding high pressure for 30 seconds and 10 seconds at atmospheric pressure. Let's run 4 cycles of this program. Clicking on the OK button starts the execution of the program. Software prompts the user for the location and the name of the data log file, which by default is automatically named by the software using a combination of date and timestamps. At this point, the expected and the actual pressure is being presented on the graph in real time. Please note that the user can tell the software to automatically scale the data on either axis of the graph. Alternatively, one can disable the auto scale feature and scale the graph manually by typing the maximum value directly at the graph axis. The first cycle is almost over. We will fast forward the video to show you all 4 cycles completed, after which the intensifier of the system is retracted to the starting position, ready for new experiment. The next example we would like to show you is the wave generator, which is using a set of available mathematical algorithms such as sine wave, rectangular wave, triangular wave, or a sawtooth pattern that could be chosen from the menu. The amplitude, offset, the number of repetitions of the program, and the period could be entered in the settings window. When the program runs, auto-scaling features could be used to display the graph in the most convenient way as well. Once again, upon the completion of the program, the system is returned to the initialization state. The ramp mode allows very sophisticated control of pressure over time by employing the user program constructed on the fly from the table of time and pressure values imported from an Excel spreadsheet, comma delimited file, or entered by user. Programs and settings could be subsequently saved into a proprietary program setting file for the future experiments. As the data are being entered into the table, the program automatically interpolates the pressure values between the points. This allows the user to create very sophisticated programs including nonlinear changes of pressure over time, just like shown here. Followed by the prompt for the log file name, the program begins. As previously, we will show you the first cycle and then fast forward the program to illustrate the second cycle. The resolution of pressure control is approximately 100 psi as shown on this graph. Built-in PID logic option maintains pressure at specified value for processes that occur at rapidly changing temperatures. The pressure jump option is employing rapid valves to facilitate changes in pressure of several thousand psi just under a millisecond. This approach may be invaluable for a variety of applications such as rapid kinetic measurements of high-pressure effects on enzymes and cultural bacteria to material stress and testing of various components and assemblies for leaks under rapid pressure changes. In this example, we are going to show you the pressure jump down from 20,000 psi to 5,000 psi. Using the Visible Items menu, user can select to display the signal from auxiliary pressure transducer included in the pressure jump kit. Once again, following the prompt for the file name, the run begins. The pressure and temperature data are being logged as well. First, the system goes to 20,000 psi of pressure, then the first valve is closed, and the pressure in the auxiliary vessel is decreased back to 5,000 psi, the target pressure after the pressure jump. Upon the expiration of the preset timer or upon receiving an electronic trigger signal from an external device, the system opens the second valve to facilitate the pressure jump from 20,000 psi to 5,000 psi in less than a millisecond. The next example shows the pressure jump in the upward direction. This time, we are going to jump from the atmospheric pressure to 20,000 psi. After 30 seconds, the valve opens and the system is again at target pressure in less than a millisecond. Let's watch this process. We enter 20,000 psi as target pressure, 30-second hold time, 10 seconds hold time after the pressure jump. The jump direction is up, none for trigger, timed end of run. When we press OK and choose to display the auxiliary pressure transducer signal at the high speed data acquisition option, auto scale the white axis, press start. Here we go, the pressure goes to 20,000 psi in the auxiliary vessel, although the sample pressure remains down at 0, the dark blue line representing the sample pressure. Now when we reach targeted 30-second time, boom. The pressure goes all the way to 20,000 psi in less than a millisecond. The Baricycler HUB440 pressure generator and a variety of specialized accessories are currently available from Pressure BioSciences. For more information about this and many other products, please visit Pressure BioSciences website or email us at info@pressurebiosciences.com. Thank you for your attention.